Hello everybody. Today from Edexcel International GCSE 921 Further Pure Mathematics book, we will solve some maths. From chapter 9, differentiation chapter, we will solve this maths. Okay, now see, apply what you have learned about turning points to solve problems. We know what is turning points is any curve. The peak position where the gradient is 0, it is said to be turning point. Where the gradient is 0, it is said to be turning points. So we know that turning points may be maximum or minimum. So how can I find out? So when any turning point, like this is a curve, y equals to like x square curve. So at first we have to do differentiation. So dy by dx, for finding the turning points, you have to write dy by dx equals to 0. From here, we will get the value of x, okay, like x square plus like 3x. So from here, if we get any value, again, we have to differentiate dy by dx, d square y by dx square. So after differentiation, which term come, if we put here x value, if d square y by dx square value we get here positive, then the turning point will be turning point or stationary point will be minimum. But if after putting x value here, if d square y by dx square value, if we get here negative, then the stationary point will be maximum. Like this is our maths, y equals to x square plus 3x. If we differentiate, we will get here 2x plus 3. So after that, dy by dx, we will write here 0. So 2x equals to minus 3, x equals to minus 3 by 2. So again, we have to differentiate dy by dx. That means it will get d square y by dx square. So what we get here? We get here 2. We don't need to put here x value because already we get the d square y by dx square value 2. This is positive. So stationary point will be minimum. If we get this is negative, then stationary point will be maximum. But what we learned from here in this maths, whenever you see a question asking about the maximum value or minimum value of a quantity, you are likely to use differentiation at some point. Most questions will involve creating a formula, for example, for volume of area and the calculating the maximum value of it. Please observe this example, example 19. A large tank, this is the tank shown, is to be made from 54 meters square of sheet metal. The whole tank is made by 54 meters square of sheet metal. It has no top. This is very important information for us. It has no top. That means the upper side is blank, no top. Show that the volume of the tank is given by V equals to 18x minus 2 by 3x cube. Number B, calculate the values of x that will give the largest volume possible and calculate what is this volume is. At first, we have to find out the value of x for which we'll get the largest volume possible and we'll get that volume. Number C, justify that the value of V you have found is maximum. We have to justify these things. Now see, how can we solve this maths? Okay. Now, see, this is the largest tank. Its upper side is blank, no top, and total, that means it is made from 54 meters square of sheet metal. That means 54 meters square of sheet metal. So at first we have to find out the total surface area of this tank. So total surface area equals to the below side is xy, and as there is upper side is no top, so xy here. The front face will be xy, and opposite side also xy, so it will be 2xy plus this part will be square shape, so it will be x square, and this part also x square, so we have to write here 2x square. Finally, we get here 3xy plus 2x square, and total sheet metal is total area is what? 54 meter square. So we have to write here 54. Now, from here, we will make y as a subject. 54 minus 2x square equals to 3xy. 3xy equals to 54 minus 2x square. So y equals to 54 minus 2x square divided by 3x. So question is that why we make y as a subject? Now see, in our question number A, we have to find out the volume where no y over there. It will be 18x minus 2 by 3x cubed. So we have to substitute this y value in the volume of the tank. So what is the volume of this tank? Volume of tank will be volume of tank will be y into x square. Okay, this is v. So y value is what? 3x here. Below said 3x. So 54 minus 2x square into x square. Now cancel this x square, so it will be x. So upper side 54x minus 2x cubed divided by 3. So if we split it, so it will be 54 by 3x minus 2x cubed by 3. So finally we get v equals to 54 divided by 3, it will be 18. So 18x minus 2 by 3x cubed. So our first part is completed. Show that the volume of the tank is given by this. So 18x minus 2 by 3x cubed, we get it. Okay. So 18x minus 2 by 3x cubed. How we did this? At first, we have to find out the total surface area of this tank. So after that, we make y as a subject. And next, we find out the volume of the tank, v equals to yx square. So here, instead of y, we put the y value, 54 minus 2x square by 3x. This x square and this x cancel. And finally, we get v equals to 18x minus 2 by 3x cubed. Okay. Now, second part, calculate the values of x that will give the largest volume possible and calculate what this volume is. We have to remember, when we want to find out the largest volume or the smallest volume, we have to differentiate v with respect to x. After that, the first differentiation equals to 0. From here, we'll get the value of x. Now see how can we do these things? Our volume we get v equals to 18x minus 2 by 3x cubed. Now we have to differentiate v with respect to x. So you have to write dv by dx equals to 18x. If we differentiate x, it will be 1 minus 2 by 3. When you differentiate x cubed, it will be 3x 3 minus 1. We know the differential formula y equals to x over n. It will be dy by dx equals to d by dx x over n. It will be n x over n minus 1. This is the formula for differentiation. Okay. So this 3 cancel. Finally, we get here 18 minus 2x square. Okay. Now we have to write dv by dx equals to 0. So 18 minus 2x square equals to 0. Then minus 2x square equals to minus 18. After that, minus minus cancel. X square equals to 18 divided by 2, it will be 9. So x equals to plus minus 3. But length never be negative. So x equals to only positive 3 and x is not equals to minus 3. So we get x value. So we have to find out the largest value of V. So volume V equals to, we have to put here 18 into 3 minus 2 by 3 into 3 cube. So it will be 54 minus this 3, that 3 cube cancel, it will be 3 square. So 18. So it will be 36. So V goes to 36 meter square. Okay. So let us check the unit. It is 36 meters square. Yeah. So volume we get 36 meters square. So now the next part, justify that. We found the maximum value of volume. Now we have to justify that the value of V you have found is a maximum. This is the most important part. So how can we justify that this volume is the maximum? So to justify these things, we have to differentiate dV by dx again. That means double differentiation. So now check, how can we double differentiate? So we have to write C number, d square V by dx square. So we'll get here minus 2x 2 minus 1. That means it will be minus 4x. So double differentiation completed. Now here we have to put the value of x here. Put value of x. Value of x, put x equals to 3. So d square V by dx square equals to, we'll get here minus 4 into 3. Obviously this is negative, so it's less than 0. So this is negative. So V equals to 36 is the maximum value of V. Okay, so I think everybody understand these things. Now I again review what we did actually. At first we found the total surface area of this rectangular cuboid, that is this box, and from here we make y subject, and after that we have to find out the volume of this rectangular box. Here we put y value. After that, which volume come, we have to differentiate these things with respect to x, and after that this dv by dx we write equals to 0. From here we get the value of x, and this x value we put the volume, so we get the maximum volume, and after that we have to do this double differentiation. So double differentiation result, if it's come negative, then the V is obviously maximum. So I think everybody understand this maths. Thank you everybody for watching. Thank you all.